Hello, Chem 111. This video is about the basics of atoms and ions. An atom, as you probably know, is the basic building block of matter, and it consists of a very small nucleus surrounded by a much larger cloud of electrons. And in fact, I haven't drawn this to scale. If I drew it to scale, you wouldn't even be able to see the nucleus. So the nucleus contains two kinds of particles. It contains protons and neutrons, and the electrons are just electrons. Protons are a particle, that has a charge of +1. Neutrons don't have any charge; they're neutral. Electrons have a charge of -1. The electrons in the atom are really responsible for the chemistry. And so as chemists, we like to think a lot about electrons. The protons and neutrons together are responsible for the mass, both of them together. Okay, so today what we want to do is just be able to figure out how many of each of these elementary particles we have in a given atom or later an ion. So let's start with an example, and you can see down here, I'm going to show you a periodic table. So let's do an example of this element here, Sc. All right, so to learn about an element, we go to the periodic table and we find its atomic number. So Sc is actually scandium, and you will find it here in the periodic table. And I want to call your attention to this number. It has an atomic number of 21. Okay, so the atomic number is equal to the number of protons, or as I'll abbreviate it, the number of P. So therefore, scandium has 21 protons. How do you know, by the way, that it's called scandium? Well, actually, this periodic table is nice. If you can read it, actually tells you the names of the elements. Sometimes they don't, and you just have to look it up. So scandium has 21 protons. To figure out how many electrons it has, we'll use the fact that atoms are neutral. And so that means that the number of protons is equal to the number of electrons. Electrons we abbreviate as an E with a minus sign. Why do we put the minus sign on? I think so we know it's not E the constant. Okay, so scandium has 21 protons, so therefore scandium also has 21 electrons. Okay. Now, the final question we might want to answer about scandium is how many neutrons it has. And you actually cannot just tell. So to find the number of neutrons, you need another piece of information, which is the mass number. You need the mass number. And the mass number, sort of hinted at it with my drawing up top, mass is equal to protons plus neutrons. The mass number is an integer that is equal to the sum of the number of protons plus the number of neutrons. And just by telling you scandium, atomic number 21, I haven't told you the mass number. And it turns out most elements can have different mass numbers. So most elements can have different mass numbers, and you have to specify which one. So, for instance, I'm going to start with, I'll start with scandium that has the mass number equal to 45. That is a thing that exists. And we write this, by the way, when we are specifying the mass number, we write the mass number in the upper left corner next to the atomic symbol, Sc. You can, by the way, write it with the mass number in the top and the atomic number in the bottom. Sometimes people do that. You don't see it very often because that 21 is redundant. Once I've written Sc, then actually if I look at a periodic table, I know that the atomic number has to be 21. All right, so in scandium that has a mass number of 45, 45 has to be equal to the number of protons plus the number of neutrons, which in this case, we know it has 21 protons plus some number of neutrons. And so if you subtract, you get that in this case, it has 24 neutrons. So that's how you figure out the number of neutrons. But you have to be given this mass number to know how many neutrons something has. And there are different versions, as I said, of different elements. So the same element with different mass numbers is called an isotope. So we can look at different isotopes of elements. So that's how to figure out neutrons, protons, and electrons for an atom. There's one more topic we wanted to go over for today's video, and that is ions. Ions are charged. And today we're going to be talk about ions that are made from atoms. There are also ions that are made from molecules, which we'll talk about a little bit later. Ions made from atoms, and they're made by either removing electrons, that makes a positive ion, or adding electrons, and that, because you're adding negative charge, makes a negative ion. And you might have seen the terminology: a positive ion is called a cation, a negative ion is called an anion. Okay, so let's do an example. And that would be how many protons and electrons are in the ion scandium plus. And when we say plus in chemistry, so plus means plus one. We don't write the one. If it's something bigger than one, we write it in. So this has one extra positive charge. So we can start with the protons. The number of protons is still 21 because it's still scandium. And as long as it's scandium, it has 21 protons. Now, this is a positive ion, so that means we removed some electrons. And to get a positive charge of 1, we remove 1 electron. So the number of electrons, I like to write my work here, it was 21 in the neutral. We took away 1, so we have 20 electrons. And I'll do one more example, which is how many protons and electrons in this ion, O2 minus. All right, so this is a new element, so we'll go back up to our periodic table, and here we find O is here. It has atomic number of 8. So that tells us that the number of protons, anytime I have oxygen in any form, it has 8 protons. The number of electrons, well, it started at 8 for the neutral, but then in this case it has a -2 charge. So I had to add 2 negative charges, and I end up with 10 electrons. Okay, so now I'm going to give you a problem, and you can stop the video and try the problem, and then you can come back to see my answer. And you'll need a periodic table to do this problem unless you've memorized the periodic table. So how many protons, electrons, and neutrons are there in each of the following? strontium 86, as we call it, strontium 2 plus, carbon 14, and N3 minus. And just as a note on the neutrons, in some cases the answer can be not enough information. Okay, so go ahead and stop the video and try those, and then come back when you're ready to see my answer. All right, so my answer for strontium 86, I need to go to my handy periodic table, and I need to find strontium, which is right here. It's got an atomic number of 38. So the number of protons is equal to 38. This is a neutral atom, so the number of electrons is also 38. And I'm given the mass number, so the number of neutrons is equal to the mass number 86 minus the number of protons. So it's equal to 86 minus 38, which is equal to 48, if I'm doing my math right in my head. 48 neutrons. All right. Strontium 2 plus, well, it's still strontium, so it's still got 38 protons. It's now an ion. We started with 38. It's positive 2, so we took away 2 negative charges, 2 electrons, so it's got 36 electrons. And this doesn't have a mass number on it, so I have no idea. Not enough information. Could be 48, could be another isotope of strontium. Carbon 14, and you'll notice even though the mass number comes before the atomic symbol when we write it, we read it out loud, not as 14 carbon, but carbon 14. That's just a thing. All right, number of protons. If you go to the periodic table, you will find carbon has the atomic number of 6. That one I do know because it's so important. This one is neutral, so it also has 6 electrons. And the number of neutrons is equal to the mass number 14 minus the number of protons 6. So this one has 8 neutrons. Carbon 14 you might know from carbon dating. It's radioactive, it's not stable. So that would decay, meaning the nucleus would turn into something else. But that's nuclear chemistry. All right, and finally nitrogen, which I'll just show you. Take my word for carbon. Nitrogen is right next to carbon, atomic number 7. So nitrogen, this has 7 protons, and the number of electrons, well, it would start at 7 if it were neutral, but it's a -3 charge, so we had to add 3 electrons. So we end up with 10 electrons, and I don't know how many neutrons this has because I haven't given you the mass number. And that's how you do this.